Hello, everyone. Today we're going to learn how to apply machine learning technologies or machine learning methodology to do polynomial regression. Previously, we have learned linear regression for single variable or multiple variables, and we have predicted house price. We have assumed that for the simplest scenario, let's say on only the square footage, the price of the house depends, and only linearly. And in the previous lecture, we have seen if multiple variables are involved, and if the house price depends on the multiple parameters linearly, how to apply linear regression for multiple variables. There are many scenarios in which the relations are not linear, and we cannot just fit a simple line. Rather, we have to fit a polynomial curve. Let's say we probably our relationship or the correlation is not linear. Rather, we have to use polynomial fit, or we have to fit a curve of second or third or fourth degree, however it is, to find out the optimal fit to make a correct prediction. So that's why we have to learn polynomial regression for machine learning method. And our scenario for this lecture, we will not use a house price prediction. We will use a salary prediction problem. Let's say we have this database, salaries.csv, and we have imported pandas, numpy, and matplotlib.pyplot. And you can see that the database looks like this. We have 10 levels, rookie, rookie 2, engineer, manager of 3 levels, and then department head, site head, regional head, and CEO. We have denoted the levels as 1 to 10. And their salaries, you can see that the salaries increase with the level, and it's not kind of linear. The higher level you are, the difference actually increases. From level 1 to level 2, the difference is only around $5,000 or $6,000. But you can see that from the regional head to CEO is like around $5,000. So the regional head salary is like 500K, and the CEO salary is like $1 million. So it's not a linear regression problem. So we will try to fit it with polynomial. Let's see how it works. So we have defined the X and Y. Definitely the level is X, and the salary, which we are trying to predict, it will be Y. So we have defined it by this, and we have visualized this X. X is an array of 1 to 10, and Y is also an array. This is the salary values are saved here. And now we actually want to compare linear regression with polynomial regression to see how the results differ. So we import from sklearn, the linear model, we import linear regression, and we fit X and Y to this. So it shows like this. And for polynomial, we have to import from sklearn.preprocessing, we have to import polynomial features so that we can actually apply the polynomial regression here. And then we have to define a variable. Let's say it's called poly_reg, meaning polynomial regression. And we are applying a degree is equal to 3. That is, we want to fit our data to a third degree equation. Instead of a line, for a line, the degree is 1, right? There's no higher degree term. But let's say we want to try with a third degree to see how the fit is. And X polynomial is we are actually fitting the data. And then we are actually X polynomial versus Y. We are fitting this. And let's first plot the linear regression curve. This is just kind of to see what versus what, and what title this is the salary prediction with linear regression, and we are applying plot scatter Y. This is the actual data as you can see from here, and another one is X versus the predicted x versus the predicted y, and this is the line. So you can see it's not a very good fit. Most of the data are actually outside our predicted curve, so the linear regression will not be very good for this, as we have already mentioned that the data set is not linear, obviously. And you can see that couple are close to the predicted curve, that is a fitted line, but most of them are very much outside. So let's now try with the third degree curve. As we have mentioned here, we are trying with third degree, and this is polynomial regression curve. This is the actual data, plot to scatter xy, so these dots. And when we plot x versus the fitted polynomial data, you can see that it fits very good. And you can see that third degree is actually sufficient level of accuracy, because you can see that most of the, actually almost all of the data actually are very well fitted. What if we try with higher or lower? We can try with, let's say, 4. We have to run this cell again. And if we run this again, actually not much of a difference for this. What if we try with 5? Actually, probably it will not, it will try to fit with a fifth degree curve, and not much of a difference, as we can see. So you can see that we can fit our curve not only with a line, but also with polynomial curve. And you can see that actually third degree is sufficient enough to make a good fit. So that's how, so that's a tutorial on machine learning for polynomial.